it could build an AI system that doesn't just answer questions, but actually understands them and provides contextual source-backed responses, right? So today, we're building an agentic RAG system that combines the power of LangChain, the open source LLM framework, SingleStore, and OpenAI to create something truly intelligent. By the end of this video, you will understand how to build an intelligent agent that can search, reason, and respond, and also the complete architecture from data ingestion to smart responses. So first, let me show you exactly what we're building. So this isn't just another chatbot. This is an intelligent agent that can ingest knowledge from external sources like Wikipedia, process and understand that information using embeddings, and store it intelligently in a vector database like SingleStore. Search semantically, so not just keyword search, but actual meaning. It finds the actual meaning so that the context is retained, and it does generate contextual responses with source attribution. So this is what we're building, and here is the complete architecture breakdown. It all starts with data collection. We start with the Wikipedia API, and then that is where our system fetches articles about AI, machine learning, any topic. You tell the system that it will fetch those articles, the content that is present in the Wikipedia. You can say LLMs, Retrieval-Augmented Generation. If that content is actually there, it will actually fetch that content. And once the articles or the data is fetched, data collection is done. The next step is text chunking. Here's where it gets interesting. So we can't just dump entire articles into a system, but we need to break these article content into chunks. So, and then that's about text chunking, and then these text chunks undergo into vector embeddings creation. So this is where we are using OpenAI's embedding model to convert each text into chunks. Vector embeddings, and then all these articles get chunked, and vector embeddings are created, and all these vector embeddings are stored in a vector store like SingleStore, and that's about the first part. And then comes the query processing and retrieval. So this is where we will see what happens when a user asks a question, right? So user query, let's say someone asks, what is machine learning? It's a simple question, but our system will try to find a very comprehensive, contextually relevant answer back to the user. And then his query, basically, the user query gets converted into vector embedding again. So that's where we call it query embedding. And then using similarity search, cosine similarity, the system tries to find the most relevant chunks from our knowledge base, and that is where SingleStore really shines, because SingleStore supports hybrid search also, which is kind of really good when it comes to search techniques. And so we are not looking for the exact keyword match, but we are finding the content that's semantically similar to the question. And like I said, that's where SingleStore plays an important role by helping us with hybrid search. And then comes the AI response generation using the LLM, and this is the final phase where everything comes together with AI response generation, and that's where LangChain agent plays an important role, and it acts as a brain in our operation, the whole architecture. The LangChain agent doesn't just pass information around it, but it utilizes specialized search tools and reasons about the context, and manages conversation memory, and also orchestrates the entire response generation process, as you can see. So it acts as the brain of our operation, as you can see in the architecture image. And finally, why this architecture we are building is powerful, because it helps us with semantic search, contextually relevant responses. It gets you with the source attribution. Users can verify information because we tell them exactly where it came from, and there is a conversation memory because we are using LangChain, one of the best open source frameworks out there. And also the whole architecture is kind of scalable. The system can handle multiple documents and